Hello, fellow problem solvers. So today we're going to be doing a problem from the 2009 IMO Shortlist, problem number A2. I suggest you try this problem out for a minimum of 30 minutes, ideally an hour, but not more than an hour and a half. If on the other hand you'd like to go along with us, I suggest you give it a go for the next 10 minutes. See what you would do. And now, let's begin. So, this is our problem. We have a, b, c are positive reals such that a plus b plus c is 1 over a plus 1 over b plus 1 over c, and we must prove this thing right here. So the first thing for these types of standard inequalities is, when does the inequality hold true? Well, when a is equal to b, a is equal to b is equal to c is equal to 1, then we have 16, 16, 16. Inequality is equality. And with that, this gives you an idea of what you can or can't do. And this also condition translates to a plus b plus c times ABC is equal to AB plus BC plus CA. And now, this is a fourth power, this is a second power. This is a zeroth, this is a minus second. So what you could do is multiply this side by this side by this, and with that you would have a homogeneous inequality, and then this condition no longer matters. Legitimately does not even matter. When you have a homogeneous inequality, you can add any condition you like, because you could always scale the numbers and change them, because the inequality is homogeneous. And that's one way of going about solving these types of inequalities, make them homogeneous, and then you can even multiply everything out. That's disgusting. I'm not even going to suggest you do that. Because what it's going to be 6, you're going to have 8th power of things, and you're going to have 1, so this is 3 squared, it gives you 9 things times, it's too much, it's not really tractable. Like if you have a computer, yeah, but if you're a human, no, you're not going to multiply 200, you're not going to have 200 terms on paper, it's just like, don't think about it. So let's try to, we have A and B and C are going to be equal, so let's try to, see what all of this is going to be less than or equal to. And the way to do this with these sort of fractions is, well, we can show what this is greater than or equal to, right? So one way to think about it is, okay, let me do something that's somewhat homogeneous, and that homogeneous somewhat cyclic in A, B, and C. And one way is it 2a plus b plus c, and that will give you something. It will give you it's gonna be decent. It's gonna give you a squared, I think. No, it's not gonna give you. It's going to give you 2a times. Actually, let's try it. So 2a plus b plus c, and now this over 2 is gonna be greater than or equal to the square root of 2a b plus c. So this times 2, square everything, square this, and then I'm gonna have 1 over 2a plus b plus c squared is going to be less than or equal to 1 over 4 times 2, so 8a times b plus c. And now, does the inequality still hold true? Yeah, this is still 16. So now the question is, have we gone overboard or not? And maybe now even 8a, I'm not sure if this is good or not. Let's check it out. So we'll have this cyclic sum of, 1 over 8, 16, so we need to prove that 1 over AB plus AC, that this cyclic sum, is less than or equal to, when we kill the 8, 3 over 2. Interesting. Could we actually do this? And we still somehow need to use our problem condition, which we haven't used. Interesting. It's not really cyclic, it's almost there. And what can we do with this? This is this would still be of power 2, right? Yeah, it's still power negative 2. And with that, I'm actually here. I invite you to, pause for 10-20 minutes and see if you would like to work with this. So what I get here is it doesn't seem so horrible, even just multiplying and now homogeneous, making this homogeneous. Because what is this? This is a times b, 1 over 8 times b plus c. Wait, it's almost like I've seen this somewhere before, like this inequality. could have been in the other direction maybe. I legitimately have forgot by now. And there's many ideas we can try. So one thing is if we multiply everything with each other, what will we have to prove? We would have to prove that, what's this going to be? It's going to be AB, A plus C, B plus C, this sort of thing, cyclic. This times 2 will need to be less than 3 times ABC, A plus B, B plus C, C plus A. Right? I mean, the way to check if this is legitimate or not is to, I think, plug in something like 2, 1.5. And it seems legitimate. So it seems like this actually could work, that we haven't pushed our estimates way too much with this. So now, what can we do with this? Can we estimate? Can we prove this thing? Like, that's my thinking now. Like, is this provable or not? And what would even happen if we, I'm thinking instead of ABC, write this as AB plus BC plus C over A plus B plus C. And now this is of, like, what's the power here is going to be 1, 2, 3, 4, and here it's 1, 2, 3, 4. So it's going to be of the same power. And then we can maybe multiply everything out and finish the problem. Yeah, that seems like it's a strategy. I'm not sure if it's the best strategy, but I'm going to just like show this to you and see if it works. Actually, you know what? Let me just multiply everything out and see what happens. And what I get is this thing right here. And now from here I need to go on. You can pause and look at this, and now with this I need to go to the next page. And after some careful and like problem solving and calculating this algebraically and figuring out I forgot this. And also I forgot this, and let me tell you the way I figured it out. And I figured it out because I saw I had 72 members on this side, and 72 like 14 times 3 plus 2 times 2 times 3 plus 6 times 3, that's 72. And I should have gotten that at the beginning. And on the right hand side I was missing, how many? I was missing like 6 times 3. I was missing 18 things. So I was like, where did they go? And here's where they went. Actually, is this 18? Was I missing 18 or was I missing? Doesn't matter. I saw I was missing something and I retraced my steps and saw, oh, this is what I was missing. And now it all ends up that we need to prove this, which is true by Muirhead, but also how would you go about proving this? Like this majorizes this, like, and the way you would prove this is you say, okay, I have 3, 2, 0, like these are the exponents. I'll take this, if I want to get a squared b squared c, I'll take this x times, I'll take the symmetric thing to it, also x times, and I'm assuming I need to take these two things as well. Let me try it just with the two of them, and I'll take them y times. And once you do the math, like you have 2x plus 2y times 2, 2, 1. So this will need to equal to, what's this going to be? 2y. This is like what you would get when applying the AMGM inequality. And once you solve for x and y, you see x and y is identical, and that all you need to do to really finish this up slowly is you have this thing is true, actually plus c squared plus b cubed plus a squared and b cubed c squared. This over 2 is greater than or equal to 2 times the 4th root of a to the power of 3, 3 to 8, which is a squared b squared c. And now you do this cyclically with all the other ones, and you get a solution. So this actually solves the problem in one way. I'm kind of sad it did. But here's another way. Instead of, at the beginning, applying the AMGM on 2a and b plus c, we could have applied, I'm just going to show you this because it's nicer. We just literally multiplied everything after doing something nice, which is a middle ground. But if we did a plus b plus c, all of this squared is greater than or equal to 4a plus b plus c. Now what we get is what's enough for us to prove is that the cyclic of 1 over 4 a plus b plus c is less than or equal to 3 over 16. And now, even multiplying stuff together, like, look at what we need to prove. We need to prove that the cyclic sum, which is going to be, okay, first of all, let's get rid of this. And I'll multiply everything through by a plus b plus c, c plus a. It's symmetric, it's much nicer. And you'll get a plus b plus c twice here. And then like times this 4 needs to, and then times what else? Well, let's move this to the other side. This needs to be less than or equal to a plus b, b plus c, times c plus a times 3. So this is what we need to prove. Okay? And we still haven't used the fact that a plus b plus c times abc is equal to ab plus bc plus ca. And we should use this fact somehow right about now. So now, what's this? Is power 1, power 1, 2, 3. This gives us a power of 4, power of 2. Well, in that case, we can multiply this side by this and this side by that, have a homogeneous inequality, and then we can look at what we need to prove. And actually, let's do that. And we have 8 times a plus b plus c squared times abc needs to be less than or equal to 3 times ab plus bc plus ca times this. Oh, it's something. And now with this, I invite you to pause for about, say, 5 to 15 minutes and see if there's a nice way, without multiplying everything through, as to how you would go about proving this. Take the 5 minutes now, and here's the next step. So this is what we have to prove, with everything being homogeneous. Yay! Which means this, you can forget about the problem statement. And now, how are we going to prove this? Well, we can use a bunch of helper inequalities here. First things first, how do we estimate maybe this part? A plus b plus c times abc. That's difficult. How do I do it? But also it pays to know a couple of these algebraic identities here. And one is that this is equal to a plus b plus c times ab plus bc plus ca minus abc. This is just like when you multiply everything through, you get this. Is actually true. So now if you multiply this by 9 and you multiply this by 9, everything's true. Like this whole thing remains true. And with that, you also know that if I like this thing right here is greater than or equal to 9abc. You just AMGM here, AMGM here, and you get that's the case. So we know that 9a plus b times b plus c times c plus a is greater than or equal to 8a plus b plus c times ab plus bc plus ca. Yay. So this is one inequality that we know. And we can, think about using it here. Or even here. And doesn't really matter which way. Let's say we use it here to estimate this. So it's like 3 over this is 8 over 3 this. So we would have that. Call this the right-hand side r. We'd have r is greater than or equal to what? A over 3, a plus b plus c times ab plus bc plus ca squared. And now what's enough for us to prove, actually, is it? Yeah, actually 8. Now it's enough for us to prove that this is greater than or equal to 8a plus b plus c. This is questionable. Is it true or not? Times abc. And now, what's enough? Well, get rid of this thing. Actually, no. This is, I forgot a square. Get rid of this thing once and this thing whole. And now you have the 8. And what's enough is to prove that ab plus bc plus ca squared is greater than or equal to what? 3 times abc times a plus b plus c. And now this is simple enough. I'll just leave it at that. It's simple enough. Because if you put a, b, b, c, ca is x, y, z, this is equivalent to x plus y plus z squared greater than or equal to 3 times xy plus yz plus zx. And now you can do this like this is equivalent to x minus y squared. You know the stuff, I'm assuming. And if you don't, like, multiply everything through and like write them as a sum of squares like this. And this actually is another way to solve this inequality, you know, using something you knew previously to solve it. And so you don't have to like just do all brute force. But the interesting part is just like the beginning, where you do something nice, AMGM, to simplify the problem. It's a decent problem, not a huge fan, but it has a trick that you learn. And as always, thanks for problem solving.